Hello, everybody.
Listen, we've tried to record this intro like 5 times. We're just gonna start the pod.
Happy Monday.
Yeah, it's Monday.
It is Monday. Fun to have an in-person pod here, first time in a while. Got a few topics we want to talk about today, but I think the main one is more React server component goodness. We've been talking a lot about that last few weeks on the pod, and I know you've been working with a side project and also a Build UI series on data fetching with React server components. So figure we want to talk about kind of something that came up through the course, the lesson you just published, and then like a follow-up conversation we had about it. So I guess to tee it up, what was the thing that we were working on that kind of led to the discussion?
So I think in the latest video, we make our first client component, and kind of the motivation for this is we want to start getting on change events, and we need a component that runs in the browser. So we need to get away from a server component. We introduce the idea of client components, and the way I tee it up is like, oh, we need the component to run in the browser. So we make a client component. And then I think I was writing the summary, or you and I were talking about it. And I said something like, okay, client components, like you might think they only run in the browser, but that's not necessarily true, because they're also going to run on the server, because pre-rendering or just rendering, server-side rendering, you need to, when someone visits your site, you need to serve HTML. So your client components are going to be rendered on the server so that initial visit can get an HTML payload. So it's kind of like a confusing thing that's like you have client components, but you can't just willy-nilly reference window or browser APIs right in render because they run on the server, and that will cause errors. And then we had this discussion about like, so client components run on both the client and the server, but server components only run on the server. And it prompted this, I don't know, you said some stuff that was very interesting about server components. So.
Right. So that was kind of like, I think that's a good way to set the story, because that's how most of us probably use React. And that's like the evolution of us using React that led to today with server components. But basically, the first time anyone used server components was in the context of a server rendered React client application already. And that's what makes it very confusing, because of the word server and what it means to people. So I think one way to tackle this whole thing is to unwind the clock and pretend that we have an alternate history where you're talking about browser code and server code, and you don't mix up the two. And then you introduce kind of the pre-rendering stuff. And I think that will help clarify a lot of this stuff. Because like we've been talking about it with people and on Twitter and at Discord, and it's confusing, just because of the word server and what it means, basically. That's a big part of the reason it's confusing. So were you going to say something, or should I just kind of keep going? Okay.
Keep going.
So the first thing is, we have these server components now, and then in your lesson, you were talking about introducing a client component. And we had this conversation, which was like, why is it called a client component? This is, I guess, like a little tangent, but like, you almost want to think of this as like a browser component, because the reason you're introducing this is to use browser APIs. JavaScript runs on the server and in the browser, but you only do things like on hover, on change in the browser. So why isn't this a browser component? That's kind of like one first way to set it up. And you said this in your video. You were like, we want to use browser APIs. We want to run code in the browser. So this is where we're reaching for a use client. But it's like, why not use browser? Because the reason you're using this is to use these browser APIs. And the reason is precisely because of what you said. It's not a browser. If it was a browser component, I guess that's what you said at the beginning. A browser component implies it only ever runs in the browser. You can actually make a component that only ever runs in the browser if you basically ignore the first render using something like an effect, which people have done in the past and people do. But this idea is why you have like type of window undefined in your code base, right? In your React client components, because when they run on the server, you need to avoid that, or just return null for that first render. So that's just like an aside. I thought it was an interesting point, though, because some people have said things like use client is very confusing, and why isn't it something like use browser, or what is this idea of a client component? And I think that's part of the answer. It's a more higher level abstraction around just using a browser. It's like Dan Abramov always talks about it as being like a portal into the world. It's like a bridge into the client, into the browser world. But anyways, that's kind of like, I think that's important for understanding all this, is that the terms client and server are higher level concepts in the React architecture. And it's not necessarily like where it's running. And a server is not necessarily what you think of when you think of like deploying your app to a server on like Heroku or in like Google or something like that. And so anyways, that's kind of just to get that out there. So let's wind back and start assuming that we have server components and client components, but we're not talking about Next.js, and we're not talking about the pre-rendering that we've been doing for years and years, right? You could imagine basically having a single app bundle like we did with the original SPA frameworks, and you make your React client components that all get bundled up into a single app.js file, and the output, the distribution, the build of your project is an index.html file, which is blank and has a script tag that loads your React app. And when that script tag loads in the browser and React is initialized and your app mounts at like a root div component, React starts rendering there. And then it does all the things that React can do. That entire like graph and that bundle, you can think of that bundle as like a bundle of client code. That's like a bunch of client code because it's running on the client. It's running in the browser after it's loaded in JavaScript, and it's going to have state, it's going to have effects, it's going to have event handlers, because that's code that is loaded in the script tag and is running on the browser.
It's made for the client.
It's made for the client. Exactly. So that's how I think of client code in React. It's like your iOS app equivalent. It's like our Ember apps that we used to write. It's like app.js in a script tag. That's client code because it's executing on the device, right? Up until React Server Components, that's like the only thing that we've had effectively. And in terms of like what React can do. Now, server components, you can imagine wanting to do the things that we can do now with server components as part of this like architecture. And so if you want something like we have now in Next, where you have a root component that can fetch a list of users and then pass it to your client bundle, you have this client bundle of client code, but you want to pass it data from React, not from like an external function or something else, like from a React component, so that you have the composition that we've talked about before with the props passing and everything. That's like a bundle of server code that is running, executing when the user makes a request to a specific page, right? And that's very different from like this bundle of app client code that was compiled and built and is loaded in a script tag. Mm-hmm. So
I think the question there,
and I'm kind of like, I haven't thought a lot about this, but I do think that, so anyways, just hopefully people can kind of follow, we're figuring this out together. But
so you say that and that all makes sense. The question I think that comes up is that, okay, so you have this server code in server components. It's doing things like fetching from the database and then maybe handing that off to client components. And then that client bundles and running in the browser. How do you get from this app, this a mixture of server components and client components that are all kind of interweaved? How do you get that into a thing that can run in the browser, that can call app.render in the browser?
So I think this is maybe the next step here. So the first step is you use the React we all have been using for years. You run a command and you get a bundle of client code that you load in a script tag in the browser. Now you introduce server components. And the way the server components actually work kind of undo what I just said, which is like you have the server components and then you have the client bundle that's loaded. Now it's actually the server components that are resulting in a bundle. So instead of the bundle being just generated at build time, let's say, and loaded once for the whole app and then making API requests, let's say that your server components are actually, the output of the server components is that bundle. And somehow, hand wavy, it doesn't really matter, that bundle gets like loaded and reloaded in the client. So the first time you run your app, at the request, the server component tree runs, fetches users, and then it returns that like tree of the app code. Let's say the app code originally was static and now you're making it dynamic. Like it's exactly the same tree of client code that you were going to ship and run in the browser. But now you've replaced like 10 static items with like a fetch to the database that has 10 dynamic items. The result is still the same. The pass of execution from server components results in that tree of client code that then gets run and put in the browser. And now let's say there's a new entry in the database. You have a button that like can refresh that server component tree. So then you do that, it refreshes it, which results in a new bundle of client code that replaces somehow dynamically on the page and starts executing that new code there, right? That's like the way to think about it, because the output of a React server component tree is like a client tree. It's like a client
It's
code.
like runnable.
It's runnable.
React
exactly.
code that's runnable in the browser.
Exactly. It's client code. That's the result. So this leads to this next thing, which is like, is it really even right to say like you're rendering React server components? Well, you are, because render in React has always been meant an abstraction. When you render a React component in the browser, it doesn't actually necessarily mean like painting pixels to the screen, right? There's two phases of render. There's like reconciliation and then commit and render and commit. There's render and commit. And the render phase is actually not about rendering pixels to the screen. That's what the commit phase is about. The render phase is a more abstract idea of getting a tree and calculating the diff of what's new. So then you have a diff and you apply the changes to the HTML in the commit phase, which is actually like drawing new divs or like setting CSS properties or whatever it does. But render has always been about like that reconciliation. So when you think of rendering React server components, you're really doing the same thing. You are running all of the dynamic code that's like in the async components. You're reconciling the result that is a tree of client code. And then what do you do with that? Like, how do you commit that code? That code is never committed to the browser because it's server code. But the result of rendering that server tree is that client code that then ends up in your browser.
Is a tree that's committable
exactly
by a browser API.
Exactly. So the reason I'm saying all this is because when you think about rendering in React, you shouldn't think about like painting pixels on the screen. Rendering should be this abstract thing. And so everything we just described, you could have a framework that does all of that and doesn't have an initial payload of HTML when you first load the application. Just like when we first started writing SPAs, Backbone and Ember, Angular, and even React, Create React App used to not have any of that. You load the app and it's a white screen because it's the client code that has to do all the painting. And this is like loading an iOS app, right? When you open up a native app, you wait for it to load, the client code to load, and the client code to start painting. And that's like what's happening here. It just so happens that the browser also has the ability to do some painting of its own if you give it initial HTML and CSS rules, right? If you like seed it with that, then it can show something useful faster. It can't do a lot of things like event handlers, right? I mean, that needs the client code to be executing in the client, but it can render things with the right HTML and CSS rules because those are like declarative and it doesn't have to execute those. So that's like this missing piece. You can have, go ahead.
Yeah, I just want to, that's super important. So I kind of want to repeat that. When we think of server rendered programming languages, we think of languages like Ruby, like PHP, and those are languages that run code on the server and they output HTML to the browser. But with React server components, that's not what's happening.
Correct.
We're running server components so that we can output a client bundle, and then we can give that client bundle to the browser, and the browser knows how to render everything. And that everything is going to be the output of the database calls that happened on the server, as well as the client components, the things that need browser APIs like on-change events and stuff like that.
And that can use client features like state and effects and all that as well.
Exactly.
Because they're executing in the browser. Yes, exactly right. When you make a request, it's like you don't want to think about you make a request to a Rails app and you get back HTML. That's not what's happening here. That's not the way to think about this. It's the right way is like exactly what you just said. So
Now, I do want to say that frameworks like Next, which we're starting at a lower level
Yeah.
than Next for this conversation,
Yeah.
but frameworks like Next do want to abstract all that away from you, and they do want you to think in terms of, user requests the about page, and I can serve them the HTML for the about page. But that is code and abstractions that Next is building on top of React Server components.
Yeah.
Just that. I think
yeah,
that's
yeah.
what-
So yeah, we'll get there but it's important if you don't care. Let's just say you were writing a native app when iOS apps first came out. You don't need a link or anything like that. That's how it all worked, and that's how it worked with SPAs too. You just load the client code, and the client code starts rendering pixels to the screen and listening for events and all that good stuff. So even in this world where you don't have any HTML coming back from the server yet, the React Server components are still a very useful part that we're missing because they're React's answer to like fetching data. Because now you can return that client code that has, you're mapping over your users and returning, users.map return li JSX element. That's the goal anyways. And now you can do that within React without having to use anything else to fetch data. You can do it in an async server component, and then you end up with 20 li items in your client code that was dynamically generated, right?
So just think about it like this. If you were writing a React app in the SPA world before server components and you needed to get data from a privileged environment like Stripe or your database, like think about, you would build an SPA, ship it to the client.
Yes.
The client would run that SPA and then start making API requests to servers that then were able to pull data out of those authorized environments. But now we kind of flip that story, and we let the first pass be pull data from those servers and then insert it into a client React app. And then when the client React, and then give the client React app to the browser. And when the browser runs that client React app and it needs to show Stripe data, it doesn't need to request that data from Stripe because that data was inserted into the client bundle by the server component. So it's a nice little like story of like, it just makes like the chain of like what everyone's responsibility. Like I do this and then I hand it off to you, instead of just handing everything off to the browser and saying, okay, you paint and go figure out the data that you need.
Exactly, dude. So well said. The goal is to have a table showing like my 20 users in Stripe. Like I'm fetching 20 users from my backend and I want to render a table with like 20 TRs because that's 20 table rows. You could like give all the smarts to the client code that can run it, render the table with a loading spinner, fetch the data, and then map over those 20 people. Or like, let's just say somehow you knew that there was 20 users ahead of time. You're just going to write those 20 lines of TRs. Like the React code it's almost like they were hard coded there. You're dynamically inserting them in there. That's what the React Server component is doing. It's like writing your React app for you with the dynamic rows, right? But like your code it's like React Server components is assembling a React client app for you. That's what you're using React Server components to do, to like assemble a dynamic client tree.
Yes.
Right?
Yep.
Instead of like giving a client app the ability to like do all this stuff. You're like, if you could like dynamically generate React client code, that's like how it works. So that's like a way to think about it. Now we're in this world where we have server components that can dynamically like give us client trees. And we have that problem where we want something to show on the initial render, because you can have all of this and still see just a white screen on the initial load. But for all sorts of reasons, it is great to be able to render something from the browser on the initial render.
Wait, before we get there.
Yeah, okay.
So one of the other differences, so based off that model we just described, when you think about, again, like a PHP or a Rails app, they're request time driven in the sense that a request comes in, server runs code, returns HTML. But with these React Server components, I think one of the really interesting things to kind of come out of this model is that those server components don't necessarily have to generate their code for the client bundle at request time. They can generate it at any point.
Right.
So you can generate it at build time.
Right.
So you can write a React Server component app that runs all of its server code at build time, let's say it's like server code, just data never changes. or
Yeah,
whatever.
blog post in a repo or something.
Exactly.
Yeah.
So it runs all its server code at build time. The output artifact is a client bundle.
Right.
I really like this term, by the way.
Client bundle. Yeah.
And then you hand that off. So you can write React server components without needing to do a request response cycle on the server for every browser you're trying to serve, which I think is super interesting because I don't know, that idea, me being a previous PHP Rails developer, that is a very foreign idea. Like server code is request time code. It's not code that's run as I'm generating.
You start
my
your
app.
server, and this is also why, in the same way
That's
that
why it's so
client
confusing.
Yeah, this is why it's so confusing, because client doesn't mean browser. It's a higher level concept that encapsulates all this. Server in React server architecture is also not like PHP start serve and then wait for requests to come in and now my server is executing code. Like when you start your server, your typical Rails or PHP server runs some code. It loads the autoloader classes or starts a database connection or whatever.
Sure, it could like fetch data and
Yes.
like populate a
Yes,
cache, but it's
but
still very
you're
your
thinking
mental
about-
model is
you-
request response
Yes,
cycle.
you're waiting for a request to come in and you're handling the request. So exactly like what you just said is that this server component tree, when does it execute? Your server can be just your computer. It doesn't have to be like a running HTTP server at all. It's not even the same thing. It's not even doing that. Let's say there's no HTTP server. It's just reading markdown files from your computer and then using that again to dynamically generate this client code bundle. But the reason it's called server is because it's using like, I don't know, why is it called a server?
Because it's not the browser.
Yeah. It's like it's really just like a computer. I guess that's why, right? Because it's running on
Computer components.
It's running on your computer as the application developer, as opposed to the user's device, the client. So that's one way. Client and server is more like user and author. It's like it's like, and it's your privileged environment, like you said. You can get secure data. But again, you're like, it's this pre-step where you're using it to dynamically build up the client bundle that is safe and
Browser ready.
able to run on the client device and do things that only client code can do. So that's server is like my code and client is like your code. I'm talking to you as the user.
Yeah.
That's like another way to think about it. Like you're coming to the kitchen and asking for, like a hamburger and like a French fries and Diet Coke. That's your giving it to me. I'm going to go back and say like, okay, the hamburger's in the freezer. Here's how you get to it. That's like my code that I'm running, in the back of the kitchen. And then like, I'm going to give you a fork. I'm going to give you like a hamburger with like a fork and a knife because you eat hamburger with fork and knife because you're weird. And then you get to use a fork and knife in your table, which is like, just run with me, right? This is like your place. This is like the client where you like cut a burger, right? I can't like cut your burger for you. No, the analogy is not quite there. No, but really it's like there's a boundary and there's stuff that you only want to do in the back of the kitchen that you're not going to do in front of your users, right? And that's like your home base. That's like the author is doing the code there and it's executing stuff, right? You have to do work. You have to do work to prepare the food, right?
So it's super interesting, just to continue this analogy. It is a good analogy. I could pre-make all those hamburgers before any customers came in.
Boom.
And then I could just hand them out. And that's the equivalent of, I guess in some sense I'm handling the request, but it's unlike like a request response thing.
Exactly
which would be
right.
more like I come into the store, you take down my order, then you go back and you cook.
Yep.
So
It's McDonald's has like 10 double cheeseburgers ready to go at noon because they know people are going to come by. So it's like you can do work in the back of the kitchen ahead of time if it makes sense, or because it's going to help you like answer those things, fulfill those orders, right? The requests. So exactly right.
Yes. The interesting thing is, I think why I'm so fascinated by this conversation is that a lot of times server components get compared to like PHP.
Yeah.
And it's like, oh, it's just PHP. Like people take the PHP logo and they put like Next.js in it.
Yeah.
It's like, oh, look what.
Yeah.
But and again, there's nothing that React server components are doing that PHP couldn't do.
Sure.
Right? PHP could just, when you boot up the server, like you said, they could just prepare a bunch of stuff so it can serve out as requests come in. But it's interesting with the server components that it's one React app. You
Yeah.
can run these components at build time,
Yeah.
or you can run them at request time.
Yeah.
But the reason, no matter when you run them, it's that you give the data to the client bundle
Yes.
so that the browser can run the client
Yes,
bundle.
yes.
Anyway,
Yep. So no, it's good. So yeah. So when you hear server in React Server components, and React architecture, server is like the back of my kitchen or whatever. It's just like your home. It's like your authoring code that's running, and it's not like a request response thing. So I think that's important. So anyway, server code dynamically generates client code. Server code generates dynamic client code. I don't know what's the right way to say it, but that's like what's going on here.
there's something you said last week where it was like there's two passes. The first
Yes.
pass,
So
that made it click through.
Yes, exactly. So far we have the server code part that you execute. It can do anything. It can run at build time or at request time. It can fetch markdown files from your computer or blog posts from a database. And then the result is a client code bundle that ends up in the browser. That's only one pass. And then that's it. So this is like the alternate history version where we have React Server components before we have server-side rendering. We haven't talked about server-side rendering at all yet. So this is why, this is the part where it gets very
your
confusing.
iOS argument.
Yeah.
Because you're saying, imagine a world where like servers don't serve HTML.
Exactly.
They serve apps that clients render on devices.
Exactly. Let's say you log into Amazon app on your phone, but you have a business account and you have a personal account. If you log in with personal, the server returns an app that is like the personal Amazon app. And if you sign in with business, it returns a different app that starts running. That's like the equivalent of what we talked about so far, right? And that's why this is like an execution of the server component layer, but the server components are not being rendered. This is not server-side rendering.
They're not outputting HTML.
They're not outputting exactly. They're not outputting HTML. They're not outputting HTML. They're outputting a client code bundle that eventually
An
is
Amazon
loaded.
Business app.
Exactly.
An app, not markup. An app.
Exactly. So, which is like the equivalent of a React tree in this conversation. That's the analogy. So the render pass, and again, render is something higher level. It's not talking about visual output. It's a render pass, gives you one of those two applications that then runs. None of that is server-side rendering. So in this alternate history, now we say, well, we don't want to just give them an app. We want to give them an app that also has an initial like splash screen, which is effectively like the initial render with HTML, because then browsers can do that, right? If you can give me an app.js script file, I'm going to run it. But if you also give me HTML, I can render it in the more narrow sense of render. I can paint it to the screen for you. So now in this alternate history, we say, well, we want an initial paint. We want pixels on the initial render and the initial paint of the app. This is where server-side rendering comes in. So you can either give me the personal or the business app, the client code bundle, and now given a client code bundle, I can render to string in Node and see what the first frame of this application will respond with, will paint to the screen once it runs in the client. And now I can serve that up. And that is server-side rendering. And that's the second pass that happens. And now we're at a spot where we are today with tools like Next, because Next supports server-side rendering so that you have an initial paint when you first load the application. But that is only talking about the client code bundle that is being rendered. There's no server-side rendering going on for server components. So this is like, I think, one way to unwind this whole why it's confusing. Because by the time you are doing server-side rendering in a tool like Next, using render to stream, render to pipeable, stream, render to string, render to HTML, or whatever, the server component execution rendering phase is long gone. It happened. It might even happen a month ago because it only happened once during the build. So React Server components are never server-side rendered. That's like, if you followed that whole conversation, you should be able to explain why. But it's admittedly a little bit of a tricky thing. We've started saying with because you see SSR and server-side rendering we started calling this like pre-rendering because I think that better captures what's happening here. You have a client code bundle that you want to pre-render so that you can see pixels on the screen during the initial paint. That's like, there's no rendering in that sentence that I just said, right? Or it's just pre-rendering, right? Because render can mean so many things. So yeah, that's kind of like what our conversation was about. And then as people have had these conversations on Twitter and learned about them from podcasts and all this stuff and the docs, people are like, well, how do React server components affect SEO? So now you should be able to answer that question. How do React server components affect SEO? They don't affect SEO at all one way or the other. They have no effect on it. They don't change it at all because all they do is take what was before a client bundle of code. What did we say? Client code bundle? A client code bundle. And they let you generate that a little bit more dynamically than before. But if your client code bundle was served up in a script file, then your app was never pre-rendered and never had any initial pixels on the initial paint. And so let's say Google couldn't analyze it. If you use a tool like Next, even before React Server Components, you were pre-rendering your client code bundle. And so you were getting initial render with HTML. You're getting the pixels on the screen. RSC has nothing to do with that because it's about generating that client code bundle to begin with.
Yeah. I really like that. So I just want to push back a little there and say, they help with SEO in the sense that you can use like the await keyword inside of the server component. So at request time, you can await a data fetch and then build that client bundle and then do a pass on that client bundle to get the HTML. Where I think like before a lot of our SPAs, we'd have like the client do a fetch and an effect. But that is not
it's
about
an indirect effect.
Yes, it is not about server components.
You're not rendering the server components. The server component is letting you build a better client bundle. That's what's happening.
Yes, exactly. So the server component lets me insert the data into the client bundle so that
your client bundle knows more than it did before.
What did you say? Initial pre-render?
The pre-render initial
has
pixels.
All that data from the database. Yeah.
Your client code bundle. Your client code bundle knows can potentially know more information than it did before because
a ton more. It can quote unquote read from the database.
Yes. So you could do that with get server side props, something like that, or a loader and Remix, right? So in the same way, the client code bundle that a Remix app or a pre-Next 13 app shipped would have as much information, and then you could pre-render it, right? If you were using one of those tools that support it, or once create React app added pre-rendering. SSR, right? So that's how it doesn't affect it. But yes, it should make it easier for people to build client code bundles that are easily pre-renderable, right? Because it simplifies the data fetching story.
That is a great. It makes it easier for the client, for you to build the client code bundle. Yes, right. That is a great answer.
Right. But yeah, so people who are asking questions like that, does React Server Component like hurt SEO, or can I like ship HTML from my React Server components? Hopefully by this point you can understand that's a wrong angle. That's not the right way to think about any of it because they're like they're like orthogonally related to each other. Sending HTML from a server like Rails or PHP does, like you could almost think of the only thing they did was pre-render trees. Actually, they like Rails and PHP without any JavaScript or any sort of client-side technology. All they could do was pre-render a static tree once, and they wouldn't ship any client code bundle. So it'd be like taking your client code bundle. Is that what we said? Client bundle of code? Client code bundle. You have your client code bundle. You have one chance, one shot, one opportunity. Do not miss your chance to pre-render your client code bundle. You pre-render it, you get rendered to HTML, and you return that. And that's it. You don't get to also ship the actual Amazon app, right? So that's one way to think about what like a strictly server-side tool would be able to do is like you make the request, it generates a thing, and then you pre-render it and you get the HTML. What's so cool about React is that you get to do all the stuff that's on the client as well. So you get to actually run the app, but you're pre-rendering the client code bundle nonetheless. So that's what's happening. So hopefully that clear. I don't know. It's not clear as mud. Like if you think about the term server and render, that's I think where this is hardest to change the way you change the which layer of abstraction we're talking about. You have to move up that ladder of abstraction like by one rung when we're talking about our React as an architecture, because rendering in React doesn't mean painting pixels to the screen, and server doesn't mean like a server that is waiting to handle incoming HTTP requests. It doesn't mean that. It means the back of your kitchen. It means where you go to prepare the bundle that you give to your clients, your users.
It is just, it is incredibly powerful.
Yeah. Oh, it's
this
incredible.
This whole paradigm is, that sounds so cheesy, but sorry. This whole thing is about building an app that
Yes.
you then hand off, because
Yes.
then just think about it, like you could say you're building a doc site. You could just hand off all the data right to the browser, and then every link that the user clicks on the browser, they never have to go back to the
Exactly.
server because you have all the docs
Exactly.
or a blog.
Exactly.
And they can render it. But if you wanted to go back to the server,
If
like
you
you're
wanted
building a
route splitting is
dynamic-
more important or whatever.
dynamic accounting software,
Yes.
you can go back there. So
Right.
it is cool that you get the client code.
The server component tree is generating your client code, and how much and how often you want to change it is like up to you. You could do it once. That generates like a tic-tac-toe game. The server tree generates the client code once, and you give it to them, and they only ever load the client code and run it, and they're just playing tic-tac-toe on their device, and the server's never involved again. Or you could do something where you have like different pages with different challenges who are playing tic-tac-toe, and someone finishes a game, and now you want to update the code that's running here. So you can go more granular and at different routes, or when data changes, refresh the code that's running. So I do like thinking about it as like you shipping an app, or you're shipping like lots of small apps. Maybe every component is like an app kind of, but because they compose together, and this server is like this more abstract concept that can be rerunning when you make a new request. It can be rerunning when Tom makes a new request. Tom could make a new request, and my app that I'm running that was generated from my React server component tree can decide this part of my tree needs to be updated. So you can have like a server driven update to the client, but it's like still a new app. And then so that's kind of like at the high level of two extremes. And then if you look at a modern tool like Next13, it's broken this down and splits it by route and lets you refresh the tree using hooks like router.refresh or revalidate path. All of that is about like re-executing the server tree, re-rendering again, which is not about painting anything, just about giving you new client
Getting a
code
new
to
app.
run.
Getting a new app.
Getting a
It's
new
like
app. But
every
then
time you opened an app on your phone, you would literally download a new app.
Exactly. The amazing thing there, again, though, is because, and this is something else that people say, which is like, why are they called server components? Like you just spent an hour or whatever, it feels like 10 hours. You just spent all this time trying to tell me why like rendering a server component is not doing what you think it is. It's not painting anything to the screen. It's actually just executing a tree, and the result of render and server land is client code. So why is it even called a React server component? Why isn't it called like a template, or why isn't it called like a React component generator? Like that's really what it is.
Yeah.
It's a React component generator. The reason it's a component that is being rendered, well, first it doesn't just like run and then give you code, right? It's doing it at a component level, and it can pass props to components. And if those props change, it can give you a new client code bundle that is like hot swapped in or whatever. It runs, it swaps it out, and it updates your client environment. The amazing thing is that first client bundle that's running, it's loaded on your client, on your user's device, could have some React state. And if it has React state, but this other part of the tree changes, you re-execute your server tree, and then you have new client code bundle that you add to the client tree. This still preserves its state up here. And so that's why it's like components that are interleaving with each other. And that's an amazing part, because if you think about how we described like the story, that would be very hard to pull off if you thought about it from the beginning. Like we have this way.
It's a whole reconciliation.
Yes, exactly. So it is exactly. Render, we said in React, is about render and commit. Render is on the first time, okay, I need this tree of 8 components. Commit, look at the DOM, none of them are there. I have the diff, I'm gonna apply the diff, create element 8 times. Now, next render phase, you have a state update. This p tag became an h1. So render, compare. Now I get a diff. That's what render's all about. And now reconcile and commit, right? You take a diff, you apply it, and you just call change element once, and you leave the rest of them the same. That's exactly what's happening with the server component tree. Render is seeing what is the client code tree that results from this render pass. And then I can see what's
And then apply the diff
to
what's
across the
rendered-
network
what's
to
rendered
what's
in the
already
browser.
there.
Yeah.
And if there's just like you wouldn't call delete element, create element. React is smart about applying diffs and reconciling. It only calls change element on the P to the H1, but the other 7 P tags stay alone. In the exact same way, if 3/4 of your client tree is the same, then the server components won't touch them. But then there's that one that changes, and so it applies the diff in exactly the same way. So that's actually, I'm glad you said that, because that is like, it's literally the same things that happening. Render from React's perspective is calculate diff and reconcile. It's like reconciliation is really like the most important aspect of rendering. And then committing is what happens like in the browser. But that is what's happening when you render these server trees into client trees. So I think that's I think that's all. Why is it called React Server Component, not something else? The answer is because it is invoked in the same way as any React component is, declaratively with angle brackets. It takes props. It returns JSX tree, and it can re-render and result in a diff that can be applied to an existing running app, and the diff can leave the existing state untouched if it hasn't changed. So that's why they're called components at all. Why are React Server Components called server components? These are like the questions, I guess, that we kind of going back answered in the storytelling. Why are React Server Components called components at all? That's why. Do server components like let you send HTML from like this from like Node or whatever? It's a mismatch in the paradigm of the question, because that's the React Server Components were not designed. They don't exist to give you HTML. They exist to give you client trees of components. Client trees, like we've been able to do for years, can be pre-rendered to give you initial HTML that paints on the first render of your app, but that has nothing to do with server components. And then the last one was like SEO and all that stuff, and it's the same thing. It's the same answer. And then do you like? I guess the fourth question, I think the one that we see a lot is like, how does server rendering work with React Server Components? Server rendering is a concept, again, that only applies to client trees being pre-rendered. And like we just said, you don't do that with server components. So the concept of server-side rendering doesn't apply to React Server Components, which again is a strange thing to say, but hopefully now you understand why. So I'm going to be thinking about this a lot this week, because I think there's a
really nice story.
There's a
I
story
do like
here
that-
where
that
you
SPA.
eliminate SSR and explain and motivate React Server Components without SSR. You don't need SSR at all to greatly benefit from the React Server Component architecture. And I think that would help explain why they exist and what problems they solve in a world where you don't serve up any HTML at all.
By the way, I think that's how Daishi, the creator of what's the state manager?
Yeah, Joe Tai and Valtio
I think
and
that's how
Zustand.
he has a React Server Component framework, and I think
There's no
that's
SSR.
There's no SSR, so he's just generating those client bundles. I'm not sure if he's going to add it in the future, but it is interesting that there are actually implementations out here that work exactly how you're describing.
100%. I'm trying to think of like the simplest example. Let's say, an Uber app where, you know, the state is server driven mostly, right? The UI in Uber is updating as a result of server side events. The driver's on the way, the driver's ready, you're en route, you've arrived. None of that's happening from client events, right? So normally when we write React apps in the client, we're doing on change, on click, on input or whatever, on submit. Those are all client side events. And the client is initializing the thing that's going to eventually cause the UI to change. In an app like Uber, it is the server events that cause the UI to change. You could open an app, a React server component driven app, that's again the client bundle running, and when the driver arrives, your server knows how to refresh and update the UI from the server. And React server components would be a great way to do that.
What a nice story.
That has nothing to do with initial render.
Server generates that app bundle. App bundle is then refreshed and reconciled with the current running app bundle on the browser or in the client, and the new update that your drivers hear, you know, or in my case, when I call an Uber and they just bunch of exclamation points.
I'm not going to freaking New Jersey.
Yeah.
Or I'm not going to New York.
New Jersey,
rather.
if you live in New Jersey and you use Uber, you know what I'm talking about.
That's exactly true. And you could have, and again, this is actually an awesome example, has nothing to do with initial render, pre-rendering, server-side rendering, initial HTML. You load the app, it's an Uber app, has all sorts of client-side state on it. You have the sidebar open, right? Have you scrolled down the thing? Are you editing your profile? Whatever. You have the sidebar open or not, but now you have a server-side event. So the React server tree is going to be re-rendered, which again is like executed. It has the new entire tree of what the UI should look like, compares it to what you have now. And the only part that's changed is like the map component that now has like a new position because of where the driver is. So that's swapped out and you're still able to like toggle the sidebar and everything. And you have no initial render going on, but server components is a extremely elegant solution to that problem that keeps you within the React paradigm and rendering components and passing props, but now lets you take advantage of like something like a server-driven event, which you could never before. This would be like a whole other thing that you would have to do. If you wanted to set this up, you would have like an effect that subscribed to a thing and then updated called set state. At that point, you are like imperatively updating the UI. The whole beauty of this is a way for you to declaratively return a new. It's just like React. React reconciliation removed the imperative part of calling create element and dot clear the tree, because if you just give me two trees, then I can do that. React can take the declarative component and do the reconciliation and go do the imperative parts. So a lot of the code that we write today that does imperative work, like setting up a WebSocket, oh, it's changed, now I need to call set state and re-render. What if you could just dynamically generate the code to begin with from the server, right?
Yeah.
And then now it can apply the diff for you.
It flows down from the server rather than the browser having so much knowledge. Yeah,
yes,
we should acknowledge it. Like, yes, you can build Uber in the browser, but
yes,
it's going to be the browser knowing how to connect to all these things, how to get updates, how to set the state for the things it should update.
Exactly.
Interesting.
That would be, I think that's, if anyone wants to do a demo of like a server-driven app that also has client-side state, I think that might be a way to exemplify the benefits of the new React server component architecture, precisely because it's going to remove a lot of the extra code that you have needed to do to wire this up on the client. Server is a natural place to respond to server-side events. And you never had a way to do that with before in React. Now you can. Like, you can update a prop from like a server. Like, it's crazy. You can update a prop of like your GPS. Like, you can update a prop of your map component from a server, from your server components, which is crazy because you could never really do that before without use effect, set this up, listen to this. Oh, this is updated. Let's change, right? So anyways, a lot to think about there though. That was pretty interesting. I like this, giving me a lot to think about.
Yeah, that was great.
Hopefully you can answer some of those questions now if you see them like us on the internet, or you better understand this whole server-side rendering. I think is an unfortunate term.
It is, yeah,
because it came before React server components obviously were created, but it's really like pre-rendering.
Yeah, it was server-side rendering It was server-side rendering a React application that was made to run in the browser. This
Yeah.
was, let's time travel back 5 years,
Yeah.
10 years
Yeah.
when all this stuff got introduced.
Yeah.
It's funny, we talk about what is a server bundle, what is a client bundle, but as soon as we end this pod, I'm just going to go back and use like await Prisma find many and be like, oh, it's just so awesome. I can just pull data from a database.
Yeah.
You know what I mean?
Oh,
Like,
totally. Oh, totally. Yep. Cool. All right. I think that's a good place to wrap it.
Yeah.
Sure we'll have more to talk about next week. Thanks for listening.
See ya.
All right. Bye.